Hello friends, today we are going to understand the relationship between TAKT time, OEE and cycle time. It includes the key definition and applications along with the numerical example. So let's begin. The first slide is what is a TAKT time? The definition of TAKT time says that it is the rate at which a product must be produced to meet customer demand. The customer demand can be into per day or per month or per quarter, or it can be a seasonal also. Generally, it depends on various factors, and one of the prominent factor is the industry segment and its order intake cycle. Formula for TAKT time is equal to available production time divided by customer demand. Few key points are it ensures production aligns with customer demand, and second one, it drives process, scheduling and resource planning. Application, it used to synchronize production lines and prevent overproduction. Coming to the next slide, it calls for the what is cycle time? Well, the definition is the total time required to complete one cycle of production for a product or service. Key points are it includes active working time. Since it is pace of the production, it can vary between workstations, and since every workstation has a unique set of work content and resources, it should ideally match or be less than TAKT time. Generally, it should be lesser than the TAKT time because every day is not the same day on the production shop floor. Problems and issues are always there to bother and make trouble the production pace. Application, it helps identify bottlenecks and inefficiencies. Next slide. What is OEE? Well, the definition is it is a measure of manufacturing productivity expressed as a percentage of ideal performance. The formula of OEE is availability multiplied by performance multiplied by quality. The key points are it indicates how effectively equipment is used. Availability, performance, and quality factors must all be optimized to enhance the usage and thereby meeting the customer demand. Applications, it provides benchmarks and improve equipment utilization. Next slide. Well, let's understand the relationship between TAKT time, cycle time, and OEE. Key relationships are dictated as below. TAKT time versus cycle time. Cycle time should be lesser than or equal to TAKT time to meet customer demand. If cycle time exceeds TAKT time, production will fall short and there will be failure of meeting the demand. OE and cycle time. OE measures the efficiency of achieving the target cycle time, which is also very essential to meet the ongoing demand. High OE ensures that cycle time remains consistent and predictable, since it bridges the gap between ideal cycle time and actual cycle time and gives predictable outcome from production operations. OE and TAKT time. High OE supports adherence to TAKT time by minimizing delays and quality issues. High OE gives predictable results or outcomes. Coming to the next slide. Well, we will understood this terminologies through a numerical example. Assume that we are producing a product for which the problem statement is as follows. Available production time in a day is equal to 8 hours, that is 28,800 seconds. Customer demand is equal to 240 units per day. Then ideal cycle time is equal to 96 seconds per unit, that is calculated by means the ideal output rate is calculated by available production time divided by ideal cycle time is equal to 28,800 divided by 96 is equal to 300 units per day. 300 units per day is the ideal output rate, which is more than customer demand. OE factors measured on the production line to produce the product are availability 87%, performance 92.7%, quality 99.1%. Remember, these all are assumptions to help understand the calculation part and terminologies. Actual cycle time is equal to 120 seconds per unit. That is ideal cycle time divided by OEE. Calculations are as follows. TAKT time is equal to 28,800 seconds divided by 240 is equal to 120 seconds per unit. Cycle time is equal to actual cycle time is equal to 120 seconds per unit. It is matching to the TAKT time. OE, we already calculated that 87%, 92.7%, and 99.1% are all together multiplied and coming to the 79.9%. To the next slide. Now we will see a few points about the ideal cycle time. The minimum possible time required to produce 1 unit of output under optimal condition. That is, no delays, no stoppages, or quality issues. It represents the best case performance of machine or process. Formula for ideal cycle time. Ideal cycle time is equal to available production time divided by maximum theoretical output. Key characteristics. It does not include losses like downtime, slow cycles, or defective units. It used as a benchmark for measuring efficiency, that is OE performance factor. Example calculations. Available production time is equal to 8 hours is equal to 28,800 seconds. Theoretical maximum output is 300 units. Ideal cycle time is equal to 28,800 divided by 300 is equal to 96 seconds. Understanding and calculating actual cycle time. What is actual cycle time? Well, the real time taken to complete a production cycle for one unit, including all observed variations like delays, operator performance, machine speed, and quality loss. Why is it important? It helps identify gaps between planned and real performance. It is a critical measure for detecting bottlenecks. It should align with or be less than TAKT time to meet customer demand. Formula for actual cycle time with OE factors is equal to ideal cycle time divided by OE performance rate. Remember, we already calculated the actual cycle time. Where OE performance rate is equal to availability, performance, and quality all together multiplied and gives rise to OE performance rate. Ideal cycle time is equal to time taken under perfect operating condition. To the next slide, example of actual cycle time calculations. Scenario, ideal cycle time is 96 seconds per unit, OE is 79.9%. Calculations, actual cycle time is equal to ideal cycle time divided by OE, that is coming rise to 120 seconds per unit. Analysis, if TAKT time is equal to 120 seconds per unit, production is meeting the demand. Since our actual cycle time rate is 120 seconds per unit, OE should be monitored, maintained, and enhanced so as to ensure to meet the customer demand. The next slide, OE insights from numerical example. What is OE? Definition. OE is a key performance matrix that measures how effectively manufacturing equipment is utilized. Components of OE. Availability. Availability accounts for unplanned downtime like changeover, machine breakdown, etc. Performance, it measures speed losses like slow cycles, minor adjustment, etc. Quality, it accounts for defects and reworks. The next slide. Finally, conclusion and recommendation. Takt time sets the pace for production. Cycle time measures actual production speed loss. OE ensures efficient use of resources to maintain both takt time and cycle time targets. Few recommendations are regularly monitor OE to identify improvement opportunity and bridge the gap between ideal and actual cycle time. Align cycle time with takt time to avoid overproduction or delays. Use takt time as a key planning matrix in lean production. Well, this is all about the three characters, 3 points, topics. Thanks, friends. If you like the content, then please do comment, like, share, and subscribe my channel. Bye. See you next time.